Good afternoon. My name is Ricardo Soto Lopez. I am the Regional Disaster Recovery Coordinator for the East Central Florida Regional Planning Council. Today we will have our webinar on green infrastructure and nature-based solutions, training for engineers, day one, with Dr. Bean, the Associate Professor and Extension Specialist of Urban Water Resources and Engineering at the University of Florida. This is brought to you by the East Central Florida Regional Planning Council, the American Society of Civil Engineers, East Central Branch, and the U.S. Commerce Department Economic Development Administration. We will have a day two with Raul Mercado, Principal Engineer of this on the 18th. Stay tuned. Here, low impact development resources that you can find on our website. This is ably put together by my colleague, Michelle Morrison. And this is additional information that we want to make sure you're aware of. This is
Rick, I'm sorry.
Recording is okay. There it goes.
Want to say anything about LID, Michelle?
No, Eban and I were just in a panel about this last week at an American Planning Association conference, and these are the some of the resources created by a low impact development grant that we worked on together, and they're on our East Central Florida Regional Planning Council website, along with a webinar that talks about them.
Outstanding. There's a QR code, and then everybody.
So again, the American Society Civil Engineers Florida section, the East Central Branch, particularly the Sustainability Committee, in which I chair. Very gracious that East Central Florida Regional Planning Council reached out to us as a co-host of this webinar. As mentioned, we're supporting from the continuing education credit side of things, but just a tidbit about our committee. You can see our core mission and function is to really just provide opportunities to our membership to help keep you informed of sustainable engineering practices. Doesn't mean we're all engineers on the committee, but that's kind of our main goal. If you are interested, there's that QR code there to join our mailing list. And even more importantly, if you'd like to get involved with our committee, please reach directly out to me. There's that my email address right there. I will also paste a link. If the QR code doesn't work for you, I'll paste a link into the chat as well, addressed to everybody, so you can click the link to join that mailing list if you're interested. So thank you, East Central Planning Council. Thank you, Eban, for presenting, and I will go quiet. Thank you.
Good to go. Excellent. Well, good afternoon, everybody. Thanks for taking some time to join us today. I appreciate Ricardo and Steve sponsoring this and putting it on. I really enjoy talking about this subject, and I think it's a pertinent topic given the state that we're in as far as regulations and changes coming down the line in the next couple months, and so really glad to kind of talk about this. I'm going to kind of talk about sort of an introduction, a little bit brief, because I think we've got more of a technical audience than what we sometimes present to. So we're going to go through some pretty high-level things quickly. Going to really kind of delve into a little bit of sort of defining what these terms are, and then talking about some of the other aspects of talking about regulations, incentives, maintenance, and so forth. Let's see, make sure I got the right window highlighted. There we go. All right, so briefly, I think we all kind of, I'm going to assume that many of us on this call are familiar with this, with this effect of as we go from an undeveloped to a developed landscape, that we have a shift in the fate of the water that falls on that site. We kind of have this shift from rainfall that would have gone into the soil and into the groundwater and maybe evapotranspirated back into the atmosphere, with only maybe about 10% going to runoff. Right, as we start to increase that imperviousness going into low density development, into higher density development, and then our ultra urban sort of downtown areas, we really are shifting a lot of that water to runoff, and that is driving a lot of our issues that we're going to be dealing with here today. Conventionally, up until sort of the 70s and 80s, you'll still see this around, that it's been pretty much trying to get water off site as quickly as possible. We're pretty efficient at trying to get water from even just rooftops as our source area, down scuppers, into stormwater pipes, or into the streets, and into our stormwater inlets, stormwater pipes, and into our nearest waterway. And a lot of this was driven by flood control. And we've seen sort of the effects of that with some of the heavy or intense storms that we've seen in the past few months all around the state. And so this has created some issues. One of them being that, if you're getting all the water off site, that's good for you. But if all that water is coming to you and your property is the one that's being flooded out, it's not such a great situation. One of the other aspects of this is that there's a wide range of pollutants that can be transported from the urbanized or developed areas through that runoff, anything from nutrients, which we see the impacts of in algal blooms, whether that's inland or on the coast. We have sediments, we have pathogens all over the place. We have organic debris and atmospheric deposition as sources of that material, and then metals and other complex compounds. Eventually, our approach really started, and this is not just necessarily in Florida, but it really started with all across the country trying to address the most common pollutant everywhere else, it seems, other than Florida, which is sediment, and using stormwater ponds to essentially capture that water, and as that water slows down, entering the pond slows down, and that sediment drops out. These ponds were also, essentially designed, initially for that flood control, kind of capturing that water, slowly releasing it, and limiting the flow rate so we didn't have downstream flooding and channel erosion. And our sort of conventional approach has evolved to this day to be fairly efficient from the drainage side, getting water off-site from our impervious source areas, rooftops, driveways, into gutters, into storm drains, and into the ponds. One of the things that's happened is, as sediments were pretty effectively removed from stormwater ponds, we're not really, there was an assumption that a lot of the nutrients could also be removed from stormwater ponds due to an assumption that they were fairly well associated with those sediments. But if you're familiar at all with some of the work that has been around for quite a while from Harvey Harper and sort of the function or the effectiveness of stormwater ponds, then you've seen that many of our ponds are not meeting sort of the presumed criteria or assumed performance of removing 80% of those nutrients. The graphs on the top are summarized data from the International Stormwater BMP database, just looking at concentrations of inflow and outflow from stormwater ponds in Florida. Sort of the trends kind of line up well with what Harvey Harper shows at the bottom. Essentially, what we see with nitrogen is that we get about maybe 25%, maybe 30% drop in the concentration, not looking at loadings. Loadings are at the bottom. And I'll go into it a little bit deeper, sort of the mechanisms for why this is happening in a moment. But we see with phosphorus that we get a much better removal from the concentration standpoint. We get about 2/3 reduction in that concentration. Comparing that with our loading reduction, that shows that we do achieve that 80% once the detention time gets up near the 150, 175, 180 days in the stormwater pond. And this makes a lot of sense if you understand sort of the chemistry behind it. I mean, phosphorus and phosphate binds to sediment particles, and as those particles continue to drop out, the finer and finer ones taking longer and longer to fall, you're getting better and better phosphorus removal. Now, the reason that we don't have the same kind of response with nitrogen is that when about half of nitrogen that comes off the landscape is going to be in a particulate form, the other half is going to be dissolved. And so what we see is that nitrogen in the particulate form, where that's organic debris or somehow tied to a settleable particle, that drops out pretty quick. And that's why we have sort of that initial bump up to about 40%. And if you notice, the phosphorus kind of starts at that 50% too, where you have, that rapidly settling particles dropping out pretty quick. But nitrogen, the dissolved fraction is not very well associated with those finer particles that stay in sort of suspension longer. And so the dissolved fraction, essentially, not a whole lot is happening within the water of those stormwater ponds. And so the assumption that we're removing 80% of our nitrogen from the landscape, this is sort of just a simplified conceptual calculation here, 10 pounds of nitrogen coming off, we're assuming 80% of nitrogen is removed. In reality, maybe we're only getting 60%. Well, that really means that we're getting about 3 times the amount of nitrogen that's discharging. We were assuming that maybe 2 pounds of nitrogen was being removed, but in actuality, we're discharging about 6 pounds or more. So that's sort of just sort of laying the groundwork here. One of the things we see is that, our urbanization is essentially driving some of our impaired water bodies. We look sort of land use on the right. For this sort of area of Central Florida, we can see that, the urbanization, the red areas, they kind of overlap with a lot of the areas that are impaired. And it's probably an argument to be made that some of the areas that are not currently impaired on the left are just not impaired yet, or have not had the time to become impaired. If you sort of see the overlay here, there's pretty good agreement between the areas that are impaired and the areas that are urbanized. Although to be truthful, this kind of looks a little bit better than many other places in Florida as far as the urbanization and impact on our urban water resources. But this does create sort of this lasting stormwater legacy, particularly when we think about how difficult it is to come back in and adjust, change, or upgrade stormwater infrastructure that has been permitted decades or generations ago. Now, one of the things with stormwater ponds is that they are designed typically for that 25, 50, 100-year storm event, depending on sort of what the criteria is for the location and so forth. So typically, we're looking at let's take a location that's sort of in this East Central area, Daytona Beach. Data here looking at these distribution of storm events, we're looking at anywhere from an 8-inch storm event for your 24-hour, 25-year, up to maybe a 12 or 13-inch event for the 100-year storm, right? So it's a pretty big storm event. These are typically your hurricanes, your tropical storms, your random storm event that's just a cloud burst that occurs. When we take a look at the overall distribution of storm events that occur completely, kind of see a little bit of a different story here. This is essentially all the rainfall that occurred at Daytona Beach Airport from 91 to 2020, 30-year record. Granted, this doesn't probably capture sort of some of the climate change that's occurring and shifting that we would expect to see, but just kind of taking it as a distribution of what sizes of rainfall events we're actually getting. We see that, essentially, some summary statistics here, 80% of the rainfall, or 80% of the days that have rainfall are less than an inch. And then if we look at a little bit higher, 90% of those days with rainfall are less than an inch and a half. And so we're not really talking about the same size or magnitude of storm events. And these are the size storms that are really driving or mobilizing the pollutants that are contributing to our water quality impacts on a regular basis. And so the flood control and the flow rate control aspects of detention ponds and stormwater control systems are kind of at the opposite end of the spectrum from the water quality size storm events. These are sort of the everyday afternoon storm events that are transporting nutrients off the site. And it's important to kind of understand that these are kind of happening at very distinctly different timescales. When we think about sort of how this has kind of occurred over time, our stormwater management goals, as I've kind of alluded to here, have kind of evolved over time since maybe, even some of the drainage goals before the 1960s, we had perspectives on needing to manage stormwater in various ways. But there wasn't really a concerted and coordinated effort, particularly not from the federal level, to enact regulations and requirements. Over time, we started to recognize the impacts of flooding, and those were sort of the primary, and that still remains the primary goal of stormwater management, is flood prevention and flood mitigation, so that we can protect people's safety and lives and property. But we started to, over the years, different topics or different aspects of stormwater management and different goals started to come into sort of the overall picture. Trying to protect the recreation and aesthetics qualities of our water resources, addressing the pollutants that are being discharged in stormwater runoff, starting to evaluate flow regime and the ecology of the receiving waters and how stormwater management can impact, preserve, or enhance those. And in recently, we've seen sort of the emergence of stormwater as a resource, and that used to be something that was just kind of on the West Coast from a water supply standpoint. But we're seeing those water pressures emerging here in Florida, where stormwater is now starting to see more and more like a valuable resource to manage. There's another sort of figure that kind of shows this transition or evolution. And in this one, this is a little bit more up to date, and it aligns with the UN Sustainable Development Goals. And I'm getting to sort of the nature-based solutions, like how does this kind of relate there? And it really kind of comes into the terminology. So when we think about sort of low impact development, and that's the terminology they're using here, in stormwater regulations, a lot of what we see here is pretty similar to the previous graph. We had the Clean Water Act that came into play, the NPDES program that came into play, and then sort of this second generation, as they've kind of referred to it here, was looking at flow regime restoration. So how do we kind of manage the long-term or the continuous long-term discharge of flow rather than just doing event-based. And then this third generation is looking at much more at the broader holistic incorporation and valuing of stormwater, really kind of looking at how do we manage stormwater from achieving the goals of improving and maintaining the ecology of receiving waters, using stormwater as a resource, improving resilience. That's been a big topic all across the state, and affecting and addressing sort of the aspects of climate change. And one of the things that we see time and time again, and it's important to kind of put that in context, is that policy is almost always going to be trailing behind the science. And you'll see that in a moment. This is another figure that I think helps to, sort of one of the earlier figures that helped me kind of to distinguish and start to understand the differences between some of these terms. This is sort of an internationally compiled graphic that lists different terms based on the primary focus of what the term is for. So on the vertical axis, we have urban stormwater management, but then we have sort of broader whole urban water cycle management. So think of like a one water supply relating to urban stormwater management kind of thing. And then on the x-axis, it's sort of looking at specific techniques, whether these are structural or non-structural, and then expanding into maybe less structural practices into concepts and just kind of broad principles. All of this is kind of under the umbrella of green infrastructure. And so here we have, different terms like, water sensitive cities, where they really have that integrated urban management. And that's kind of looking at, it's a very broad principle and conceptual, but it does range sort of from that whole of urban water management to the stormwater management practices. low impact development, low impact design. We'll kind of get into those definitions a little more here in a bit. But that's kind of, again, kind of conceptual broad principles that does have a specific focus on stormwater management, but links to and starts to reach up to some of those whole watershed or whole urban water cycle aspects. And then when we look at sort of the individual stormwater practices, BMPs, and one of my favorite acronyms, SQUIDs, which I think is from Europe, stormwater quality improvement devices and stormwater control measures, these specific practices are really sort of, focused on just urban stormwater management. And if we kind of consider this aspect of this term green stormwater infrastructure, understanding that infrastructure is essentially the everything that provides services to society around us. We have telecommunications infrastructure, wastewater infrastructure, we have power and energy infrastructure, and we have stormwater infrastructure. Stormwater infrastructure being typically our pipes and drainage, our control structures that manage that stormwater flood and all of our other goals of water quality and so forth. The green aspect here is really two things. Number one, the green is the vegetative and trying to bring in the living or biological side of trying to enhance the stormwater infrastructure or utilizing vegetated systems as part of our green stormwater infrastructure. As a comparison to green infrastructure, there's things that are examples of green infrastructure that don't necessarily apply to stormwater infrastructure that I'll show in just a moment. We kind of boil this down and look at sort of where is there an overlap between these terms and topics. Green stormwater infrastructure, if we kind of break out sort of nature-based solutions and so forth, they kind of occupy a very similar space. And I will say that nature-based solutions, green stormwater infrastructure, and LID are oftentimes used, terms that are used interchangeably. And at first, I think that was something that I did as well. But I hope that by the end of this, you'll have a much clearer understanding of what those terms mean and what are examples of practices that fall into one, but maybe not the others. So I've tried to simplify this a little bit and sort of plot out where nature-based solutions are. And I think of nature-based solutions, the way to define those are essentially, the natural infrastructure that is solving or addressing our needs or providing services to us. Green stormwater infrastructure, again, is primarily focused on stormwater management. But nature-based solutions can be more than that. And so if we start to kind of look at what are some of the examples of practices that would map on here, I think that we start to kind of break out and understand sort of where they are. So in the best management practice, stormwater controls, we have stormwater ponds, permeable pavements. Permeable pavements are sometimes green stormwater infrastructure, but they don't have necessarily the vegetation there. But infiltration practices, kind of the same thing. As we get into like stormwater wetlands, bioretention, green roofs, vegetated buffers, those are obviously green stormwater infrastructure. But they're also nature-based solutions. They have vegetation and basically they rely on the natural functioning and natural processes. You can even think of sort of the self-organization of ecological engineering principles. That is essentially, nature-based solutions and green stormwater infrastructure. Living shorelines, though, don't necessarily provide a lot of stormwater benefit in stormwater management. They secondarily do by preventing maybe erosion in a stormwater practice, but the living shoreline themselves are not necessarily managing directly the stormwater. Same with wetland restoration, and I want to distinguish that from stormwater wetlands. Wetland restoration is a nature-based solution. We're enhancing the natural system to solve, maybe it's improving our water quality or improving water that's retained, but essentially that wetland restoration, the primary goals are not necessarily focused on stormwater management. As we get into sort of low impact development, these types of concepts that overlap in this space, utilizing such practices and strategies like disconnecting imperviousness to allow impervious areas to drain onto green space. You know, it's sort of leveraging that green space and then using that natural function there. It's sort of kind of tying all those together. But things like compact development, conservation development, those are more broad principles that essentially are the layout of a site and how do we optimize that to fit into what the site offers. And other aspects that are less geared towards the whole urban water management might be like minimizing impervious cover and narrowing streets. That's really specifically targeting reducing urban stormwater management, but it's sort of more of a broad principle or concept. You could argue that it's a specific technique or practice, but overall, it's not necessarily managing the stormwater. It's trying to reduce the amount that's being generated. So if we kind of think about sort of the distinction between sort of what is nature-based versus green stormwater infrastructure, I think this diagram helps to kind of illustrate this between stormwater practices. I like how it goes from mechanical to biological, and just a note, this is the reference for where this document comes from is on the vertical axis on the right. But essentially looking at how are we migrating, the typical stormwater management is on the mechanical side, but how are we able to incorporate sort of the biological and ecological systems to provide services for stormwater management and treatment in our urban areas? And if you think about this from a very simplified, big picture concept, our conventional approach is, looking at pipes and catch basins and ponds, which we've kind of seen hasn't necessarily given us the best water quality treatment and efficacy. And while the optimal picture on the right isn't necessarily a realistic image for an urbanized area to try to achieve that or replace that, it does kind of it does touch on sort of the approach of how do we incorporate these natural solutions into an urban area to provide similar functions or enhance those functions over the conventional approach. So as I mentioned, I typically have started to differentiate between low impact development and green stormwater infrastructure. And this is particularly became apparent, as I'll show you, as we kind of think about how regulations come into play or where those regulations are coming from. When we talk about low impact development, this really is sort of the site planning and design strategy. This is at the very beginning of the site development process. And it really is looking at how do we minimize how much of the site is being altered and how much runoff is going to be produced, and with the goals of trying to avoid and minimize that runoff from the site. Green stormwater infrastructure, these are your types of practices, and you can even think of this as the nature-based solutions of the practices that are being put in place to retain, detain, filter, and evaporate, detain, filter, and store stormwater in the urbanized or developed area to mitigate what could not be avoided and minimized. So there's a lot of overlap between there. And this is sort of what I mean from the LID and GSI or nature-based solutions, kind of going from the beginning of the development process through the engineered final plans. When we start out with a site, a lot of times we're looking at, the goals are mapping the natural infrastructure, and we're looking at how do we avoid disturbing this. This is sort of the conceptual broad principle of how do we, how are we strategic with where we place developed areas within the overall site to minimize those impacts. Then we're looking at minimizing the runoff by limiting those areas, enhancing or kind of preserving some of those pre-development hydrologic features, and integrating sort of practices that a lot of times will reduce or kind of, if there's a disconnecting some of those impervious areas so that we can reduce the overall runoff that's being produced from the site. Finally, when we think about sort of the water that could not be avoided or minimized from the site, that's where the mitigation with GSI, nature-based solutions, and even our stormwater ponds for flood control come into play to employ those natural processes to perform those ecosystem services that we need to achieve pollutant load reduction, flood control, and so forth. I like this as an example to kind of show and differentiate between LID and GSI. This is a local commercial site here in Gainesville, big box stores. You can see big parking lot. They have utilized basically bioretention or swales in between the parking stalls. If you look at between the at the bottom of the screen. However, there's a lot of parking and a lot of rooftop and a lot of imperviousness here, so it doesn't show efforts to reduce or minimize that imperviousness. Although you could argue maybe there's some attempt to disconnect the imperviousness with the swales or bioretention in between the parking stalls. Overall, it's really more of this is what I would call green stormwater infrastructure, but not necessarily low impact development. Coming back to this kind of concept and getting back to regulations and incentives, the regulatory structure that affects these processes as we think about sort of the development timeline are a bit different. When we think about the GSI, the green stormwater infrastructure, this falls under sort of the DEP, water management districts. This is where the ERP program comes in, and a lot of the alphabet soup of TMDLs, BMAPs, MS4s, and so forth. A lot of that is really kind of driven or controlled from the Clean Water Act, from the federal programs down to the state level and water management districts. But the other side of this, of the layout and sort of how a site is designed, a lot of this comes from sort of the local constraints and approval process that happens. And so there's a lot of things that can actually be done at the local level to improve and provide a fertile groundwork for green stormwater infrastructure and nature-based solutions. One of the things that happens with codes over time, though, I was kind of talking to someone recently. I said, codes and ordinances, and they're not like a brand new house that was all well planned out and designed. It's like a house from the 1920s that has had like 7 or 8 different owners, and each one had their own vision of what the next add-on or remodeling needed to be. And none of it really flows together. There's different flooring in different places. And so a lot of times there's some unintentional consequences or unintentional restrictions or prohibitions that affect the use of green stormwater infrastructure practices or nature-based solutions. One of those, for example, is the requirement for curb and gutter. This essentially requires that impervious areas be directly connected. It's really difficult to if you were required to have a continuous curb along a street, there's not the opportunity for that to have a break in that curb and water to basically discharge into an open space that might reduce the water quality and reduce that runoff and reduce sort of the overall runoff calculations. And that sort of indirectly prohibits swales. The use of traffic islands and medians, there's regulations or local codes that restrict or prohibit how those islands can be used. If there are limitations on being able to utilize that space, that green infrastructure in those opportunities, essentially, then you're not going to be able to take advantage of that and incorporate that into the stormwater system. This kind of looks at another sort of lens on this same site. Is this relationship between high parking amounts or sort of minimum parking requirements based on square footage of the stores or the businesses and the overall imperviousness. Right? So this is particularly relevant to commercial and residential codes, where it essentially artificially increases the amount of impervious areas. There's some opportunities to change the requirements to allow for example, pervious parking in some of these, or reduce the parking requirement minimums. So particularly when there is seldomly used space or when there's timing of different businesses operating at different times. So, for example, maybe you have a store that operates typically 8 to 5 Monday through Friday, and the next door is a house of worship, some type that has a service once a week, or that's when the majority of the parking that they need is being done, and those don't overlap. There's not necessarily a reason to have duplicitous parking for both of those. And so one of the things that we've looked at doing is, and helping communities to do, is to audit their codes and identify where these restrictions or prohibitions are in their codes. We developed a tool that helps them to identify sort of these weak areas that could be addressed or could be improved when the opportunity is right. So, for example, when the county commissioners or city commissioners makeup is open to making changes or want to prioritize those changes, this is one of the tool that's available to be used there. The code audit tool, just to touch on it, I'm not going to go in depth here, kind of breaks the code audit process up into about 16 different categories, and every question is kind of scored on a scale from 0 to 4 based on how it is either prohibited all the way up to being a required practice. And that scoring provides the basis for identifying where you have higher scores or stronger codes versus lower scores that are maybe not as encouraging or are more restrictive. But the other side of this, we talked about the local side, but there's been a lot going on the state side and the ERP side. Many of you are probably familiar with the recently passed and approved stormwater rules for the ERP program that are going to essentially take effect in about the middle of next year. Some of the main changes that took place were essentially changing the way that criteria is defined from a presumptive criteria to a technical criteria, or basically technology-based criteria. So touch on that in a moment. But it also looks at this aspect of net improvement and performance standards and making sure that is more uniformly and consistently applied. It also provided an opportunity or a way to provide additional stormwater practices, BMPs or GSI or nature-based solutions that can be used rather than it having to go through such a huge process. It kind of provides a framework and a list of those options. So I think it provides a groundwork for this being able to evolve and become better over time. One of the other main things was that it strengthened the requirements for operation and maintenance of stormwater systems. I'll talk a little bit about that here in a moment later on too. We're involved in some of the aspects of that. Just to kind of touch on more specifically sort of the change that's happening here with the stormwater rule, the water quality requirements for stormwater are going from this technology-based presumptive compliance to performance-based. I apologize, I think I used technology-based where I meant performance-based on the slide before. But essentially, the structure overall is going to remain mostly the same, other than how you determine the performance of certain BMPs and looking at how they're going to achieve the load reductions. For example, here, one of the things that has changed is that for all non-impaired sites, instead of total nitrogen having to be reduced by 80%, it only now needs to be 55%. But that's not a presumptive compliance. That is a performance-based, and that has to be based on data collected and monitoring of those practices to show how they are actually achieving that. Most of the other sort of removal rates are staying pretty much the same, but notice here that the pre or post also has to be achieved. So it's sort of an and, so keeping that in mind as well. Inspection reporting, essentially inspections are going to have to use a checklist or some similar format that were included in the rules. And these are going to be required annually or maybe every few years for projects, but that's going to have more of a formalized process. So what do we do here? So there's sort of two aspects for addressing some of these new rules with the stormwater, with the ERP program. One aspect is reducing the overall stormwater that's generated from the disturbed site. So how do we do that? A lot of this is looking at the aspects of low impact development, planning, site design, and that can be achieved at the local level. So reducing sort of our disturbed area, going for more compact or cluster development, reducing some of those parking areas or parking minimums, and looking at these aspects of LID, disconnecting imperviousness, and looking for how those disconnected portions can reduce the runoff that's being generated and the loadings, and incorporating in some cases GSI or nature-based solutions that are in the landscape or in the disturbed area that are not necessarily for the water quality credit, but to reduce your runoff curve number. Now, if you're using GSI practices for the water quality, there are ways to do that, and I'll touch on that in a moment. But that is the other option. Sort of how do we, if we can't reduce the loading increase, we can improve or increase our load reduction and treatment train practices that are in the system. What this aspect kind of looks like is essentially moving a lot of the water quality treatment, or a portion of it, upstream of our flood control practice, which is our typical orientation. So how do we improve or incorporate different BMPs or GSI, nature-based solutions for that water quality treatment into the landscape? Think back to those dead spaces, maybe in the right-of-way between, say, the street and a sidewalk. We might be looking at opportunities to take advantage of that space to capture, treat a portion of runoff, not necessarily flood control, but that is an additional incorporation of function into the landscape. Okay. When we look at the sort of treatment train and putting these practices in series, this is sort of what I'm getting at as far as like a portion. We're not looking at GSI necessarily having to take on a huge burden of the nutrient load reduction. So here's an example of how this might be achieved with a stormwater pond. Let's say, for example, the stormwater pond, we design it so that it has the detention time that reaches a 44% nitrogen removal. And we're trying to get down to a 55% reduction. Well, if we back it out, the pre-treatment upstream of that pond really only needs to be about 20% of the nitrogen that is coming into it. Okay, so it doesn't necessarily need to have, it doesn't need to remove 70, 80, 90% of the nitrogen all in that GSI or that nature-based solution there, that BMP, right? It's really just a small portion, but that's got to be sort of the workhorse for consistently providing that amount or that percentage of our nutrient load reduction. And so when we look at sort of the BMP efficiencies, this is sort of the basis of where a lot of that's going to be derived from with designing and looking at the credits. Essentially, these are broken out. This is a table from DEP, from their TMDL and BMAP program that essentially is going to be the basis for how to calculate those load reductions. We have sort of this online, offline retention of BMPs. We have sort of the different criteria for the different configurations. And noticing here, we sort of have this, BMP trains and stormwater practices in series. That's going to be sort of the framework for, the basis for calculating the credit that those can provide. Moving on to incentives, I always like providing this or touching on this slide, and it's intentionally blurry. It's intentionally hard to read because the overall concept, within like a second or two of looking at this, you probably picked up that there's one option among these different colors that stands out. Right. And we're talking about cost here. So there's, each of these axes on the vertical side is a different way of communicating cost. And essentially, it's the blue bars here are green roofs, comparing them to infiltration practices, permeable pavement systems, cisterns with irrigation and either indoor or not having indoor, and then biofiltration. And I bring this up, or I show this, because not all BMPs cost the same or are as cost effective for either the area of imperviousness that they're treating or for the volume that they're going to be treating as well. I know I'm running short on time. I'm going to try and pick up pace here to get through, and I may have to cut off a few of my slides at the end, but I want to get through these aspects here. This is sort of a summary and illustrated. This was a study of a review of some designs of sites that EPA did for looking at different costs. And if you look at these, you have the conventional development costs, LID, or the conservation or the GSI development costs, and we have the cost difference, the percent difference. If you notice, there's one that is negative, right? And it's sort of strange. It's like, it's like, why is this one so much more expensive with the LID? It's essentially twice as expensive. Well, we can always make bad choices, and I'll go back to that sort of that green roof cost aspect. That this is an aspect where maybe the best selection wasn't there. And if we look into the details, we find that this LID proposal also included rooftop rainwater collection systems on each house. Well, if we try and put a rooftop collection system on top of each house, the cost of that is going to outweigh doing almost any other type of practices on a per lot basis. Even if we did all permeable pavements and bioretention, doing that kind of an implementation is not a wise or cost-effective solution. The white projects here are the ones that were on the previous slide, and it shows sort of the different LID techniques, and I've highlighted the Kensington Estates ones, the one that was so expensive. If you notice, it's a little bit different. What stands out from the practices that are used on this site versus the ones that were cost effective, all the other ones essentially were using bioretention. Only a few were using permeable pavement. Some of them were using reduced impervious area. They were using swales on all the other practices. So utilizing the low-cost practices is one of the main ways to be an incentive here for yourself in looking at making these projects cost-effective. LID and GSI does not mean putting green roofs on everywhere and paving everywhere with permeable pavement. Although there are situations within the development continuum where those make sense. Green roofs make a lot of sense when you have no other option and you have a high premium on reducing water quality size storm events in an urban area, and you don't have other space to achieve that function. But when we start looking at sort of this rural transition zone up to urban, we see this sort of a gradient. At the low cost green development, we're seeing swales, cisterns, rain gardens, bioretention. And then as we start to get into more urban areas, only then do we see things like permeable pavement. They have a little different definition here where bioretention is worked into the parking lot. It's a little bit of a different structure there. Curb cuts, those kind of things. The shape or what GSI and nature-based solutions look like evolves as we move across this continuum here from urban or from rural or agricultural to more urban areas. And this is really what an implementation of LID site planning and green stormwater infrastructure might look like. On the left, we have the complete clearing and maximizing of lot sizes, wide roadways. And on the right, we have where we've utilized select design principles, narrowing the roadway, incorporating bioretention and bioswales, sort of low-cost stormwater management practices. And we've also have a large area of conservation, reducing the urban or reducing the imperviousness. I'm going to skip over this kind of case study just in the interest of time, but essentially this kind of goes into showing that, when we offset the amount of curbing, stormwater pipes, catch basins, that concrete, that actually costs a lot with our stormwater drainage system. So that frees up a lot of additional funding to be repurposed into green stormwater infrastructure. In this case, they use permeable asphalt or pervious asphalt to reduce the runoff. It increased their paving cost, but essentially was a bit of a swap there. They also reduced the need, in this case, for detention basins and outlet control structures and the amount of clearing that needed to be done. So by freeing that up, we were able to repurpose those costs, and we have a cost breakdown here that shows that on the site and essentially create a very high functioning site on a lower footprint with a better site design. I will touch on that operation and maintenance is key. One of my favorite quotes that I think applies to urban stormwater management is that another flaw in the human character is everybody wants to build and nobody wants to do maintenance. It's important to compare apples to apples in that our operation and maintenance that is required for a highly visible bioretention cell, for example, shouldn't be compared to deferred maintenance or avoided maintenance in a hidden stormwater pond. Those are kind of things that are not necessarily looking at them at the same from the same perspective. One of the aspects too to consider is the short-term replacement costs versus the routine maintenance costs. Those can really kind of vary when you're comparing GSI, nature-based solutions, with conventional stormwater infrastructure. Really kind of looking at where does, what's the trade-off there over the life cycle of the system when we compare sort of routine maintenance, which overall could be higher for GSI, but the replacement cost might be lower for the GSI. And I think about, for example, replacing a stormwater pipe versus regrading or cleaning out a swale a few times. Those kind of things are appropriate comparisons. I will also note that we are working on a stormwater inspection and maintenance program that is to satisfy the requirement for those that are not PEs or not working under a PE that would be doing stormwater inspection and maintenance as part of the new requirements for the ERP rule. That will be released tentatively in spring 25 ahead of the new the enacting or the effective date of the new rules. Just want to touch on a few things here. LID really starts at the beginning in site design and looking at how do we implement those broad principles and concepts early on to reduce, avoid, and minimize the amount of runoff that's generated and utilize what the site offers. The GSI and nature-based solutions are great opportunities to mitigate and manage what runoff could not be avoided, while also providing additional benefits of aesthetics, diverse vegetation, and can be very cost-effective options for managing stormwater. There's several sites that have some resources. This is the Florida Friendly Landscaping Program. If you go onto the Green Stormwater Infrastructure site, you'll see some of our resources there for some of the green infrastructure maintenance and planting tools that we have for that, as well as some webinar series and our inspection checklist. We also put together a website with photos of high quality GSI projects around the state, with some additional information and background on each site. So if you'd like to check out and see some of those examples, some of them are definitely within this region, have a look over there at gsiphotosflorida.org. Really great way to help illustrate and help others who may not be as familiar with these types of practices to see what this type of an implementation looks like. And then I'll just put a plug in for GSI, floridadep.gov. This is sort of the clearinghouse for all of their GSI resources, where they are essentially trying to provide information for those who are novice to this, all the way to technical experts. So with that, I'll be happy to answer some questions.
We have a few questions, more than a few questions in the chat.
Okay.
Should I read those, or should I get them to you?
Where should I start? Let me see if I can pull this up. I see some. All right, hold on just a second.
I've got one.
All right.
Actually, I think I only really saw one was,
okay.
Why would you use bioretention and not take the water quality credit?
It's not that you wouldn't take it, it's just how it is counted in the permitting side of things. If you take the bioretention, so for example, in the ERP, typically you're not allowed to take water quality and volume reduction, or basically to reduce the imperviousness. You kind of have to set it aside as either it is a stormwater control practice or it is reducing the source area. So that's kind of how the permitting works. Essentially, if you have pervious area or some type of GSI, that reduces your overall impervious area, reducing your curve number, which reduces your runoff volume. So it effectively works as a runoff reduction practice. If you were to route a drainage area to that bioretention and take the water quality side, you have to model and show that it is recovering that volume within the design, the required period and so forth. And each of those practices essentially requires that sort of modeling to be performed for the load reduction.
Okay, thank you. The other question, and it has been approved by Steve, is can we release this recording and your slides to the attendees? And can we post them on the East Central Florida Regional Planning Council site?
Sure.
And I think even the ASCE would like to do the same.
Sure, I'd be happy to.
Okay, all right,
Be
thank
honest,
you.
I'm pretty involved with ASCE, and I'll note we're actually in talks. I'm leading the organization of it'll be the 2026 LID conference that ASCE puts on every couple of years. We're looking at holding that in Central Florida through EWRI and ASCE, looking at probably late January, early February 2026. So keep an eye out for that.
All right, thank you.
And Eban, I didn't realize how plugged in you are with EWRI and ASCE. So
All right.
kudos to you, and thanks for the tip about the EWRI conference, the LID conference coming to Central Florida, you said?
It is, yeah. Probably Orlando, but we've got to kind of work that out with ASCE leadership and get all that kind of worked out. We're still kind of in the early phases, but that's sort of the plan. You could say it's the word on the street, so to speak. So,
Well, we support that.
fantastic.
Thank you for your engagement, Professor Bean. Stephen, thank you for your collaboration from the beginning. The next webinar would be on the 18th, same time, 12 to 1. And we'll have our colleagues we'll have our colleague Raul Mercado, principal engineer, who put together the project in Lake Worth.
Yeah, I'm looking forward to seeing Raul's talk. I think that's going to be a great one.
Yes, sir. Thank you for your
Probably can come
engagement.
back.
Thank you all for your engagement.